Expectation. Expectation is exactly what it sounds. It's what you expect to happen. So if I give you a couple of information about a certain trial or an event, this is what you expect to happen. Expectation is also just known as the average. What happens the most? The mean. Right? If on average it rains 3 times a week, you would expect it to rain 3 times a week. So there's been a couple ways to find this. The easiest way, the expected value, is just you multiply the number of trials times the probability. Boom, done. Right? Oh, if we're gonna flip a coin 100 times and they expect to fall heads 50% of the time, you just multiply 100 times 50, you expect heads to be 50 times. That's kind of the idea. Right? Just, I have a certain probability, I have a certain number I'm doing, just multiply them together. That's your expected value, that's your average value, whatever. If I give you a table, then we're going to use this formula right here. It looks fancy, but just kind of break it down. Remember, it's the same thing we always do. That just means sum. That means x, your random variable. And that's the probability. So if I give you a table, and I said, here's x, here's p, and this is 0, 1, 2, and this has like a 5%, 2%, 3%, and that's how it adds up to a 1. If you want to find the expected value, just do what it says. Multiply x times p, and then 1 times 2, all the x's times all their p's, and then sum, add them up. That's how you find expected value. If I just give you 2 sets of data, multiply them. If I give you a table of data, multiply them, add them up. That's it. Here are your formulas in your formula sheet that apply to this. Right, so this is the actual one, expected random variable, discrete random variable. It's this thing. Notice how that symbol right there, that's called mu. That stands for mean or average, right? So that's all it is, like we talked about. That's sum. That's the x value, and that's probability. So if you have a table like the one we just kind of did, just do that. Multiply all the x times the probabilities, add them up. Now, all these have to do with binomial distribution, which we'll talk about in a couple of lessons. But notice again, there's mean, there's expected value, right? So you have both e to the x, expected value. This is just if you have a probability in the number, you just multiply them. Easiest thing in the world. Now let's do an example. Each time a footballer kicks for a goal, he has a 3/4 chance of being successful. That sounds like a probability. In a particular game, he has 12 kicks on goal. So that's the number of kicks I have on goal. How many goals do we expect him to kick? So again, same idea. My expected value, here's a symbol for it. There's 2 formulas really, but I don't have a table. All I have is 2 numbers. So it's n times p. Just the number of times you expect he's going to kick it times the probability he makes every single time. You get 36 out of 4 or 9. You expect him to make 9 goals if you have 12 shots on it, based on the average of the previous thing. So that's a very basic expected value. Multiply the probability times the number of times it happens. There you go. Now let's do one with the table. So example 6, find the mean of the magazine store in data 2 of example 2, explain what it means. So we did this actually example earlier. It's with the magazine stuff. Ignore all this right now. Right, where one magazine was a 23% chance, 2 was that. So here's the table. Now, since I have a table, if I want to find the expected value, or the mean, which is also expected value, remember this is equal to this, and that stands for mean. All I'm going to do is the formula. Expected value. Now this one has a table, so I'm going to use the other formula. Equals sum of x times p. So I'm going to multiply my x's and my p's. So right here, 1 times 0.23 plus, because of sum, 2 times 0.38 plus 3 times 0.21 plus 4 times 0.13 plus 5 times 0.05. If you add those all up, you're going to get 2.39. That's the expected value. What does it mean? On average, you expect about 2.5 people to buy a magazine. On average. Again, on average, so it could be continuous. Or to buy 2.5 magazines, let's just say, right? Because it's the number of magazines you buy. So on average, a person buys about 2.5 magazines per trip to that store. Okay, now let's apply this to games. First thing we gotta talk about is what's considered a fair game. Well, a fair game is when the expected value is equal to 0. What really they mean is this. They mean the expected value is equal to the cost to play. That's what a fair game is. On average, you average out to ER 0. But the general idea, if it costs like $10 to play a game, if the expected value is $10, then it's a fair game. If it costs $10 to play a game, but you only expect to win $2, then it's not a fair game. It's a house's advantage. If it's the other way around, oh, it only costs $2 for the game, but you make $10 on average, play that game like crazy. Just keep voting for Mudlark. Right? But that's the general idea of a fair game. The expected value, so they say it equals 0, but they really mean it costs to play. So whatever the cost to play, that's what expected value should be. If that's true, it's a fair game. If the cost to play is lower, then it's unfair in your advantage. If the expected value is lower than the cost to play, then it's unfair to the house. And let's do a quick example to show what we're talking about. In the game of chance, the player spins a square spinner labeled 1, 2, 3, 4. So right here's my square spinner. I don't need to draw this on board. 1, 2, 3, need arrow. 4. Right? The player wins the amount of money shown on the table alongside depending on which number comes up. So right, it says if a 1 comes up, you get $1. If a 2 comes up, you get $2. 3 comes up, you get $5. 4 comes up, you get $8. What's the expected return of 1 spin in the spinner? Okay, so right, the expected return of 1 spin in the spinner is this. So here's the numbers. Your winnings is X. Right, numbers doesn't really do that. It's just more descriptive. It doesn't really tell you anything. The winnings is your X. That's how much you win per value there. I don't have my probability yet. Well, we could find that, right? It's an even 4 table 1. They're all gonna be the same. They're all gonna be 1/4. Odds of getting 1 is 1/4. Odds of getting 2 is 1/4. If you're just drawing a spinner around, so they're all even, right? So that's all to getting all of every single one. A says what's the expected return of one spin, expected value, right? So you just multiply these things, add them up. So it's gonna be $1 times 1/4. Plus $2 times 1/4 plus $3 times 1/4. Actually, that's wrong. It's not $3, right? We're only getting paid $5. So, I mean, we're getting paid $5, not $3. If it lands with it, you get paid $5. So $5 times 1/4, and right here, right? If it lands with 40, you actually get paid $8. Big winner. If you add these all together, you can factor the 1/4. 8 plus 5 is 13 plus 2 is 14. 15 plus 1 is 16. 16 by 4 is just going to be $4. Right? So that's your expected value. Every single time you spin it, you expect to win on average about $4. So that's A. The expected gain of a player if it costs $5 to play the game. So that's a little mischievous wording there. Right? You expect to make $4. It costs $5 to play. So if you play this game, now on average, you're going to be losing $1. That's what's going on there. So expected gain is negative $1. So I'm not cool with that wordplay, but it's a negative $1. Would you recommend playing this game? No. You don't lose $1 every single time. It's inefficient. So no. Right? You don't expect, if you want to play a fair game or one that's in your advantage, not one where you're losing money every single time. Right? So that's kind of the general idea. Right, figure out the expected value, multiply the winnings, not the number, the winnings times the probability, add them up, and that's what you expect to gain. A fair game is when those two things match. So they charge $4 for this game, it would be fair. If they charge less than $4, it'd be not fair, but in your favor. Anything more than $4 is not fair in their favor. So let's do a few more examples. Here's a quick one. If a dice is roll simultaneously 180 times, how many times would you expect to get a double? Well, let's first figure out how many times you could double. Right? So there could be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Now we could go list out all the possibilities when you roll a die, but really we know there are 6 possibilities in the first die, 6 possibilities in the second die. So if you multiply them together, there's 36 possible combinations of things you're going to get. And these are the only ones that give you doubles. So there's only 6. 6 out of 36 probability of getting double, or 1 out of 6 probability of getting double. Right? Because again, 6 times 6 is 36 combinations. only these 6 give you doubles. So your probability is 1 over 6. They're going to roll this 180 times, so your expected value is then times p, or 180 times 1 over 6. Let's move on. A single coin is tossed once. If heads appears, you win $2. If tails appears, you lose $1. Right? So remember, this is what's going on. So we're tossing heads and tails. If heads appears, you win $2. If tails appears, you lose $1. How much do you expect to win when playing this game 3 times? So first, let's talk about one time. Right? Heads, tails. Odds of getting heads is 50%. That's here's our x. Here's our probability. Odds of getting tails is 50%. So the expected value of one time you're doing it, just remember, multiply and add. 2 times 0.5 plus 0.5 times -1. I get 1 minus 0.5, or 50 cents. Right, so on average, you're supposed to win 50 cents. Right, that's my probability. So now they're saying, how much do you expect to win when you play the game 3 times? Well, that's my n. Expected value is the same idea still. N times p. So 3 times 50 cents. You win a whopping $1.50. Woo! You could, I don't know, do something with it. I'm going to talk about this next one in general. I'm not going to go into specifics because I don't want to waste your time. But let's look at this one. In a random survey of electorate, politician A discovered that residents' voting intentions in relation to himself and 2 other opponents, B and C, the results are indicated alongside. So here's the results. He polled so many people, he got 165, 87, 48 for C. Estimated probability of any chosen voter in the election will vote for A. Well, this is our general want over total. So A is going to be 165 over whatever the sum of 65 plus 87 plus 48 is. Likewise for B, it would be 87 over that mess. And then for C, it would be 48 over whatever that number is. Now look what this one says. If there are 750 people in the electorate, how many of these would you expect to vote for A? Well, remember, our expected value is just n times p. Right, because now we're done with the box now. I don't have a box anymore. That's this for the first part. Where n is 7,500 people. And our p is whatever number we got here. Whatever that happened to be, that's our p. Likewise for B, it will be 7,500 people times whatever this value is down there. That's kind of the idea. One final example and then we're done with this video. A person playing a game with 2 pairs of coins. If 2 heads appears, 10 pounds is one. That's pounds, the British currency. If a head and a tail appear, 3 pounds is one. And if two tails appears, 5 pounds is loss. How much would you expect to win playing this game once? Well, so again, that's kind of a loaded question. We actually got to do all the work for that. Right? Our different possibilities are, we could get 2 heads. We could get if a head and a tail appear, so head and tails, tails and heads. So head, tails and heads like that, one of each. And then if 2 tails appear. Now we kind of done this before. We actually know the probability. Well, let's do the value first, right? 2 heads, you win $10, 10 pounds. Heads, tails, or tails, heads, one of each, you win 3 pounds. 2 tails, you lose 5 pounds. Right? We already know the probability of this. There's only one head in the set of 4, so 1 out of 4. There's 2 of these in the set of 4, so 2 out of 4. And then there's one of those in the set of 4, and we toss 2 coins, so 1 out of 4. So that's our probability table. And now if we want to find the expected value, all we do is, it's a table. We multiply and we add. 10 times 1/4 plus 3 times 2/4 minus 5 times 1/4. If you add all that up, this is 6, this is -5, this is 10. 16 minus 5 is 9 over 4. The expected value on each turn is 9 over 4, or 2 1/4, or $2.25 pounds, whatever. That's how many expect to win if you play it once. If an organized game wishes to make an average of $1 per game, how much should he charge to play? Well, again, we expect to make $2.25 every time we play. So if he wants to make $1 each time, you're just gonna add $1 to it. $3.25, right? That way, on average, we make $2.25 to play, but he's charging us the $3.25 to play. So we're losing $1 every single time now. But again, this is because the organizer wants to win $1 every single time. So he just adds $1 to the average number. And that's the way it works. Shady, but it's the way it works. And that's it for this lesson.